Welcome to today's session. Today's session is going to be a continuation or a part two of the previous video I did on the ABO group. I think or I realized that there was some questions about reasons why family have or is a family consisting of two or four or five people can have different blood group types. So today we are going to understand how blood groups are determined as well as how they are inherited. So please stay tuned. And if you are new here, please don't forget to press on the subscribe button, like this video, and share to a friend. The ABO blood group system is determined by the combinations of genes inherited from parents. So the same way we inherit certain genes that make up our physical appearance or how we look from our parents, is the same way or a similar manner that blood groups genes are also inherited. So based on that, there are about three main genes when it comes to ABO blood groups, and these three genes are both represented by the same letters we saw in the previous video when I was explaining about the antigens. So in terms of the ABO blood group system, the genes are, or the three main genes are A, B, and then O. So based on these three genes, you can inherit any of them from your parent depending on the group your parent has. So we are going to dive more into how they are inherited. To the three main genes that determine the AB blood groups, an individual can only inherit one copy or one gene from each parent. You can only inherit one gene from your mother, one gene from your father. You cannot inherit two genes from one parent. And out of these three also, O is a recessive gene, and then A and B are dominant genes. When we say a gene is a recessive gene, it means that unless it is inherited as double copies, it cannot manifest its features. When it is inherited as a single copy in combination with another gene, then it is suppressed by the dominant gene. So A and B are dominant genes, and that is why when they are inherited as A and B, we can have a blood group type known as the AB. But because the O is a recessive gene, whenever it combines with any of the dominant genes, then it is suppressed by the dominant gene. To understand this better, let me give this scenario. When you mix salt with water and you taste it, it will be salty depending on the quantity you put. But in this case, we can say because it is salty, salt is dominant and then water is recessive, because when you combine them together, you are only tasting salt. You can no longer taste water. So based on what I explained earlier, or I just explained, if you understand it well, let's now understand the possible combinations of genes that will give us the blood groups or the blood group types we have. So when an individual inherits the genes AA from parents, because A is dominant, when you combine the two copies of A together, the blood group type it will give us will be blood group A. But if an individual inherits A from mother and then O from father, because O is recessive, the A will suppress the O and will still give us blood group A. If an individual inherits two copies of B from parents, because they are both dominant, they will manifest and give us blood group B. But if an individual inherits a B copy from father and an O copy from mother, because O is recessive, it will be suppressed by the B, which is dominant, and will still give us blood group B. If an individual inherits A copy from father and B copy from mother, because they are both dominant, they will manifest equally, and that will give us the blood group AB. And if an individual inherits O from father and O from mother, because they are both recessive, they cannot suppress each other, so they will also manifest and give us the blood group O. And this is the manner in which the genes of the ABO blood group are inherited. So if you inherit two copies of recessive, they will manifest equally. If you inherit two copies of dominance, they will manifest equally. But when you inherit a dominant and a recessive, then the dominant suppress the recessive. Let's understand how determination of the Rh factor is done. In my previous video, I explained that there is a presence of an antigen known as D antigen on red blood cell surface. So its presence will make a blood group positive and its absence will make a blood group negative. So if you want to determine that, for the sake of this video, I represented its presence to be capital D and its absence to be small d. So when it is present, or when I'm doing some examples which will come later, I will represent it as capital D when it is present, and then small d when it is absent or recessive. So when it is absent, it can also be recessive because it cannot manifest its features. In order to understand this better, let's take some examples. For example, if we have a mother who is blood group A positive and a father who is blood group O negative, because the mother is blood group A positive or blood group A, according to the ABO system or inheritance pattern, the mother can only pass either A or O gene to her children, while the father can only pass O to the children. So children from this family can either be blood group A or blood group O. And we are trying to determine the Rh factor because the father is O negative and the mother is A positive. Children in this family or from this family can have both positive blood and negative blood depending on which one they inherit from their parents. So when we combine these two together, it means that a child who is coming from this family can only have blood group either A positive or A negative, or O positive or O negative. A child from this family cannot have B positive or B negative, neither can a child have AB from this group because the father is O and the mother is A. Here comes a second example. If a mother is B negative and a father is O positive, in the inheritance patterns of the ABO, because the mother is blood group B, the mother genotypes or the mother genes can be A or O. So the mother can pass either O or B to her children. But because the father is O, the father can only pass O gene to his children. When we come to the Rh factor, because the mother is B negative and the father is O positive, children from this group or from this family can also have blood group positive or blood group negative. And when we combine these two together, because the mother is B negative and the father is O positive, children from this family can either be blood group B positive, B negative, O positive, or O negative. Children from this family cannot have blood group type A. Neither can they have blood group AB because their parents are B positive, B negative, and then O positive. And the third example, if a mother is blood type A positive and the father is blood type B negative, in the inheritance pattern according to the ABO system, because the mother is A, the mother genes can either be A or O. So the mother can pass either gene A or gene O to her children. And because the father blood group is B, the genes the father can pass to his children are either gene B or gene O. And according to the Rh factor, because they are both positive blood and negative blood from both parents, the children from this family blood groups can be positive or negative. And when we are combining these together, a child from this family can be A positive or A negative, B positive or B negative, AB positive or AB negative, O positive or O negative. And because the parents of this family are A blood group and B blood group, there's a possibility to have an AB blood group in this family, or there's a possibility to have a full house blood group types, if I may put it that way. So all the four blood groups, you know, if your father is A positive or B positive and your mother is B negative or B positive, the possibility of a child inheriting any type of the blood groups we know is possible in this way. But if there is an O parent and then either A or B parents, there is not possible that an AB blood group will come from this family. If you have watched this video to this point, I want to say thank you, and I also want to believe that you have an idea of how come there are so many, or there can be so many different blood groups existing in the same family, and also why sometimes you may be willing to donate blood to save a relative or a loved one who is from the same family as you. Sometimes it can be a mother wanting to donate blood to save a child, or a father wanting to donate blood to save his child, but that blood is not compatible. These are some of the things that will make that impossible or possible. And also, sometimes when this happens, we want our patient to know that it doesn't make you an adopted person. You are from the family directly by blood, but these are the things that make certain things like that come up. It's not by mistake, or we were not exchanged from the hospital as we hear stories. No, you are directly related to the family, but based on this system of inheritance, sometimes the blood cannot be compatible to a biological mother or father.